Hello, y'all. What's up? We are going to look at day 3 today, geometric sequences. So let's get started. I got to zoom in. I have smaller paper. So there we go. So what we're going to look at today is instead of having a difference like subtracting, we're going to look at a ratio. So there's a multiplier. We have to figure out what we multiply a number by to get the next number. So if you look at this, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, so R is 3. A1, just like it was yesterday, the first term. AN is the last term. We don't have that here. N, we don't have an N because we don't know how many. Because there's a dot, the 3 dots indicate that this goes on forever. Okay, so, and this part right here, I just want to make sure you know what the ratio is. So all you have to do is take this number and divide it by the number before. 20 divided by 10 is 2. 40 divided by 20 is 2. 80 divided by 40 is 2. So R is 2. A1 is still 10. Okay, I like you to be able to divide. It makes it easy if you get a fraction. So to figure this one out, you just say 1/16 divided by negative 1/4. Which a little practice, we know that's 1/16 times negative 4 over 1. So that is negative 1/4. And if you were to do that the whole way, you'd figure out R is negative 1/4. Now in this one, A1 is negative 1/4. That's okay that they're the same. AN is 1 over 256 because that means the last 1, 2, 3, 4, and N is 4. So all of our vocabulary is still the same. So let's try one of these. And our formula, as you can see, is A1 R to the N minus 1. Okay, so the variables you need this time are A1, R, and N. So write the first 5 terms of a geometric sequence whose A1 is 2 and R is 4. Well, this is easy to do, right? We can do this. A1 equals 2 times 4, right? And we can figure that out, but we can also put it in just to find number 1, and as soon as we find 1, we don't really need to do all that because we know that the first term is 2 and the common ratio is 4, so 2 times 4 is 8, times 4 is 32, times 4 is 128, times 4 is 512. So we don't need this part here. Is if we have the first term and we have R, we can just write all the terms without very much work. Okay, let's look at this one again. I'm going to write this formula down. I keep writing it over and over again. I think you should too, so that way you're used to it. Okay, find the 9th term of the geometric sequence whose first term is 4 and whose common ratio is 0.5 or 1/2. So N equals 9 because they said the 9th term. A1 is 4 because the first term is 4. Common ratio is 0.5, so R equals 0.5. So I just like to color code those so you can see what's going on with that. Now let's write this down. So we're going to say A to the 9th equals 4 times 0.5 to the N minus 1. 9 minus 1 gives us 8. So you can just pause this for a second and plug it into your calculator. If you use the 0.5, you're going to get this. And if you typed it in this way and you put a half in, right, then you're going to get 1 over 64. So depending on how a question's asked, whether you want a decimal or a fraction for your answer. All right, let's try another one. Write the formula and find the 10th term of the geometric sequence 6, -2, 2/3. So we always want to figure out what we know. So N is 10. A1 is 6. So we just need r. So what is negative 2 divided by 6? That's negative 1/3. So it's negative 1/3. They told me this was a geometric sequence, so I know it works. If I find r, I can use it. I don't have to test them all. So now we're going to say the 10. This just means I'm finding the 10th term equals, what does that equal? 6, right, times negative 1/3 to the n minus 1, right? And n is 10, so we're going to raise that to the 9th power, and we're going to type that into our calculator, and we get negative 2 over 65/61. If you were to put in 1/3 and not use the fraction button, you're going to get negative 3.048, 8 times 10 to the negative 4th. Okay, either answer, it just depends on what's being asked of you. Okay, so these I think are actually a little bit easier than arithmetic because we just have the one formula, we don't have two. Now we're looking at the sum. So if I have a geometric sequence, a whole list of numbers, can I add them up very fast? Well, let's see. All I need is the first, how many I'm adding up, and what my ratio is. So let's see what we know. Here we know that A1 is 1, right? AN, the last one, is negative 2187. Again, on that, I'm practicing some vocab. Sometimes we need it. N is 8. And R is, what is R? Negative 3. Now, how did I figure out N? I jumped ahead and I figured that out. We didn't really know N in this case. So you tell me how you would solve for N. Well, I can say, well, I have this formula, right? And I can say negative 2187 equals 1 times 3 to the n minus 1. So negative 2187 equals 3 to the n minus 1. So I could go to my calculator. Now I can do one of two things. I can take the log of both sides, which will allow me to pull the n minus 1 down, or I can just say, you know what, that's not going to be very big, so let me just try. Let me try 3 to the 7th. Oh, that actually worked. I was going to say, if you tried 3 to the 8th, it'd be too big. So 3 to the 7th worked, so I need 3 to be to the 7th, and this says n minus 1, so I need a 7, so it's going to be 8 because 8 minus 1 is 7, so n is 8. So I just tried with my calculator and figured that out. Once we know that, we can just plug everything into the sum. So the sum, right, of the first 8 numbers equals A1 times 1 minus negative 3 to the 8th over 1 minus negative 3. Don't forget when you're subtracting, r is negative 3, so you want to write 1 minus, because what does 1 minus turn into? You got it, a plus. So now punch that into your calculator. You can pause the video, make sure you know how to do it, and that would equal 1640. Of course, this one and this one, you know how to do those. We recognize them as a math 0. So math 0, again, remember that is, let me get my calculator. That's math and 0. And then it pulls up the form for you, and all you have to do is type it in. So pause the video for a second and type these two in and make sure that you can get those. That one's 127, and this one is 1598.46. Okay, just pause and make sure that you're okay getting those summation symbols into your calculator. All right, one last little piece about today. You remember yesterday when we talked about arithmetic sequences, if a sequence went on forever, if I said 1, 2, 3, 4, ... if it was arithmetic, you could not add it up because it went on forever. Well, that can work in a geometric, because in a geometric we're multiplying to get to the next number. And if r, right, is a fraction, notice here it says r must be between 1 and -1. That means like 1/2, 3/4, -2/3. It can't have a bigger number on top, like 4/3, because that's bigger than 1. But if it's a fraction, then we can add it up. Let's think about y. If I told you r was 1/2, or let's do something ridiculous, let's do 1/8. If I started with 1/8, if I started with 1, I multiplied by 1/8, I'd get 1/8. And then if I multiplied that by 1/8, I'd get 1/64. And then so on. And you would notice that as I have an r of a fraction, if I keep multiplying by a fraction, whoops, my number gets smaller and smaller and smaller. So eventually it actually turns into 0. So we are allowed to add up an infinite sum for a geometric because it's a ratio, and as you multiply fractions, you just eventually really get close to 0. So you can just type these in. So let's just, if possible, let's answer that first. Is this possible? Yes. Why? Because r equals 1/2. Is this one possible? Yes, because r equals 1/10. Is this one possible? No, because, oops, r equals 3. 3 is not between 1 and -1. In other words, it's not a fraction. Okay, so to add these up, we can do the formula. Now, how would I find A1? Well, I just plug the first one in. The first number here they gave us is 0. So anything to the 0 power is 1, and 1 times 5 is 5. So A1 equals 5. So that would be 5/1 minus 1/2, which is 5/1/2, which equals 10. The other thing you can do is you can type it into your calculator, but your calculator, notice this goes from 0 to infinity. Your calculator doesn't have an infinity button, so what you're going to do is, of course, x and 0, whoops, 0. Then when you go up here to put in infinity, it's 99e. The E button is right over here on the divide. It's a blue divide key. So you have to put 99e to get to infinity. And then you just type it in 5 times 1/2, right? Raised to the n, which for you is just x. Let's make sure this works. And there we go. We have a 10. So the one thing you need to know is 99e stands for infinity. So your calculator simply doesn't have the infinity symbol. Okay? So let's try these two. So you take a second, you can pause me, and let's type these into your calculator. And this one is going to come out to be, if you type in 1/10 with a fraction, you'll get 50/9. If you type it in as 0.1, you'll get 5.556. And this one we can't do. So let's take a second and you try that one. So again, notice if you go up, you can copy and paste that. The 99e is not going to change. It's just the only thing that changes is this. Whoops. Right? And you can hit the enter key and hopefully that works. And there we go. I did 0.1, so it's 556. If I copy this, I can go over here. I can delete that. And instead of, well, I think I went too far. I can put in alpha y equals a fraction, and I can do 1/10, and then it will give me the fraction answer. Oh, it didn't this time. Usually it does. But anyway, if you did it by hand, you would get this. If you need any help, just watch this video again, and I hope you have an absolute phenomenal day.